third way, the last way we're going to look at these mechanisms is this time I want you to tell me if the mechanism that I'm proposing is consistent with the rate law expression. Because here's the deal. I can never prove a mechanism to be true. Okay? No mechanism can be proven correct. You say, what do you mean? It can't prove it. What's the point of learning it? All right. Well, you have to realize that I can't see atoms combining. I can't see electrons leaving and going somewhere else. I can only see the end results. And I can only see those end results by manipulating the conditions in a reaction, in an equation, usually through several trials, and then seeing what happened. Okay? Then being able to predict, like, well, gee, this guy didn't have any effect. When I manipulated him, he had no effect. He must be zero order. All right? So that's how you have to do this. So let me just show you what I'm talking about here. Basically, I can only determine if a reaction rate or a reaction mechanism is consistent with the rate law expression. I can't say that's actually correct. And you know what? In actual chemistry, there are reactions that have more than one possible mechanism. And I don't just mean SN1 versus SN2. I mean, like, there's more than one consistent mechanism, and we really don't know for sure which one it goes by. Right? We're not positive because there's more than one possible way it could happen. And I can't actually slow it down and see these guys do that. Now, here's what I want you to do. I'm going to do one example and one example only on your the notes here. Actually, when it comes to the book, you're going to do something a little bit different. All right? I'm going to open up to those, and I'm going to have you guys do some of those without copying all of them. I do want you to eventually copy this, but right now, just copy this, the overall reaction and the rate law expression. We're going to leave the actual mechanisms go until after I'm done talking about them. So if I give you this equation and that rate law expression, in the past, up till now, what have I asked you? I've asked you questions like, what order is NO2? What order is CO? What would happen if I doubled the concentration of NO2 and tripled the concentration of CO? Okay? I asked you those kind of questions up till now. Now I'm going to do it a little differently. I'm going to ask you, I'm going to give you the mechanism and say, does that mechanism make sense to that rate law expression in that equation? So do not copy these. I will give you time, but because we all copy at different speeds, and I don't want to tape the whole thing, you can copy them after I'm done, just looking at them. So let me just put them all up here. That's mechanism number 1. There's mechanism number 2, it's a 2-step mechanism, and there's mechanism number 3, a 3-step mechanism. Now, which of these is consistent with the rate law expression that I've given you here? That's going to be the question at the bottom of the second worksheet. All right, the second worksheet you're going to be doing in a few minutes is going to have the top half that's just like what you just did, but the bottom half is going to ask you about whether the mechanism is consistent with this. This is why you have to understand it and not just do these by rote. All right, let's watch. Looking at this first mechanism, is that one, which is a one-step mechanism. One-step mechanism means the only step is the slow step. Notice I labeled which is the slow step in these other ones. Why didn't I label it here? Because it only has one step. It is the slow step. It's the only step. It's the rate determining step. Now, does this one make sense to that rate law expression? What do you think? Jesse?
No.
Why not?
Because CO is involved in the slow step.
Yeah, here's CO, but I don't see him in the rate law expression. So I know for sure that this guy cannot have gone by this mechanism. I don't know which one it may have gone by, but I know for sure it couldn't have gone by that one. Because the rate law expression, if that were the mechanism, would have looked like this. Rate equals K, CO, NO2, both to the first power. You agree? All right. Because he's involved in the slow step. Each one of them is involved in the slow step once. All right. Let's look at this guy. Is this guy consistent with, so by the way, that guy, when you do copy these when I'm done talking, you'll say inconsistent or put an X by. That is not consistent. This guy here, is he consistent with the rate law expression as written above?
Yes.
Yeah. Here I've got NO2 in the slow step being used twice. It's exactly what I was looking for. But you say, well, CO's used late. Yeah, but he's used in a fast step. Kind of like, think back to my demo, okay, with the 3 people standing up here. All right? So absolutely, this guy is consistent. Let's look at the last one. Is this guy consistent with the rate law expression that I've given you right here?
No.
No. And the reason being, let me show you. The slow step is right here. That's all that really matters for the rate determining step. That's all it's going to tell. That's what's going to tell me who's involved up here. If I were to write the rate law expression for this guy, he would look like this. Rate equals K, what? CO to the first power, right? To CO. Okay? Because you say, well, NO2 is used down here, and there's other crap going on. It doesn't make any difference. All right? The slow step is all we care about. All right. Now, having said that, and that's the general idea, I want you to copy that right now. But I'm going to also go over some other problems.